Alrighty. Hello everyone. My name is Jacob. I am an instrumentation engineer working with Binar. I am the primary engineer working on all the hardware, avionics, the flight software and payloads. And as part of that, I do a lot of electronic design and build a lot of things that do stuff in space, tends to be, but sometimes also on the ground. So what we're going to be going through today is an extension from what Fergus was talking to you about this morning. Just going through electronic circuits and actually building them physically on a breadboard, testing them, and then checking that everything works correctly, and perhaps getting some stuff working with your dev boards. So, what have we got up? So we've got the picture of the breadboard up here. So first thing we're going to go through is getting your power rails set up on the breadboard itself. I'm going to work out how to turn this. No, I'll do the dot cam and I'll switch.
That diagram, if you want to bring it up on your own computer, is in section 1 in a GitHub page. So we can help you find that later.
Yeah. So what's that? How do I switch between what I'm presenting here, Meg?
Windows P, and then you can go duplicate if that's what you want.
I just want to have this on the. There we go. Yeah.
Yeah, that's up now.
Yep.
Where did your question mark? Yeah, when oh, in the, so you get to one payload hardware development. There you go, microcontroller board 10 labels. So in one, so in the very parent top. Yeah, there you go. Has everybody found it? Is anyone still having trouble finding the microcontroller? Alright, so go in the GitHub, go up to level 1, not 1.1. Level 1 and then scroll down. There you go, there. I'm an idiot. Oh, it's alright, I get stuff right before my face all the time. There you go. So payload hardware and there you go. So these with the GitHub, these are not labeled in order, so it's not like day 1 was 1.1, it's more grouped by subject. So if you, what I'll do is at the end of the program, I'll give you all an updated schedule with the numbers so that you can see what goes with what, and it's easy for you to follow along. Maybe I'll even have that ready for Monday. And then if you're wanting to review anything, you can.
Cool. So once we've all got the diagram up, I've also got the diagram that Fergus has done of the breadboard up on the screen in the center. The diagram on the center shows, as Fergus was talking about, the power rails on the breadboard. These are where you're going to be wanting to route your power. A lot of the components you'll be working with will need to draw electricity or sink electricity to these power rails. And it helps to have a lot of pins available for when you are running things in and out of them. So on the breadboard itself, if you have a look at it, you'll see that there's the two rows that have got one, it's got a red line and one's got a blue line on both sides. The blue indicates the ground and the red indicates the positive voltage. It doesn't have to be, but that is just a convention, and I would recommend sticking with it, because when you go to debug your breadboard circuit, you want to be able to look at it and understand what you're doing. So in the picture that Fergus has done, he's showing the same thing, where he's got the red and the black line. That's our power and our ground rail. So we're going to want to connect our power and ground rail and our breadboard to the power and ground on the microcontroller board that you've got there to use the power from the microcontroller board to run the electronics on the breadboard. So if we can grab jumper wires.
Is there a couple of wires from their bags? Male to female and male to male leads, I think?
Maybe we didn't give them
Oh,
parts of their
we
bags.
didn't?
So what they can do is they can come grab
All
some
right.
from up here, or they can trim their own using this solid core wire.
Yep, all right.
All right.
Do you want to show them how to strip their
Yeah, of
ends
course.
on the document camera, or
Yeah.
just in real life, whatever
Yep.
you want?
All right. Do you want all instructors on deck for this one?
I learnt with side cutters. They can learn with side cutters. Okay, so should we do it on the dot cam or here?
I don't know. Try it on the document camera, and if we can't see, we'll let you know.
Yep. All right, I'm going to squeeze over here.
Maybe just, we only have a couple of these jumper kits, so maybe we have like one in this area, one in that area.
All right. So, everyone can watch. You can either use those as pre-stripped wires. They come in little lengths and they're all different colors, or you can do what I used to do when I was a kid and
Make everything.
make everything. Yeah, because we didn't.
You can get the exact right length.
True. Also, that's expensive. I didn't have money for that. I just stole wires from things I pulled apart. So we've got a bit of wire and we've got our side cutters. So we're just going to cut a chunk off like that. I'm actually not really sure where. I need to draw.
Here, maybe I can make the field of view a bit bigger for you, and then we can. I'll just tell you if we can't see it. I think
Cool.
it's fine, but it's not very good design.
So we've got our bit of wire. Obviously, we can't plug this in because we don't have the actual conductor exposed on the ends. It's still got the insulation. So we can grab our flush cutters and we can size up around about how much we want and then just gently squeeze. If you squeeze too hard, you'll just cut the end off like that. So you want to just sort of gently squeeze, and then I will rotate the wire around just to get, I don't know if we can zoom in enough to be able to see that.
There is a zoom in button there. I don't know.
I can't see what I'm looking at, that's all. Nor whether it's focused. But there should be like a little indentation around the insulation.
It's fine.
Kind of visible. That's the indentation. That's where I'm going to pull from to be able to get the insulation separated off. So you can hold that and you just pull off like that. And then you'll be left with the wire exposed inside. We can do that on both ends. So we do the same thing again, just snip around and then pull off. Ends up being a little bit bent, that's all right. And then all the little bits of wire, we'll just chuck those in the bin so we don't make a mess.
Yeah, the bins are
So now we've got a bit of wire. I'll do another one with the red one, and then I'll get everyone to decide whether they want to do it this way or whether they want to use the little wires out of the box. Alrighty. So, can I get everyone to grab one black and one red wire, either from that or from this? People want to do it this way, they can. Yeah, just cut a bunch off. Yep. In the micro, the breadboard. Yep. Yep. Not yet. Yeah. All right. So on the dot cam, so we go from our 3.3. All right. So next thing's next. Can I get everyone to come up here and pick an LED? We've got a lot of colours, so just pass that around and grab one out for yourselves. See? All right, so does anyone remember when Fergus was doing his presentation when we did the calculation for the LED resistor? Maybe?
Was it onward voltage?
Yep. Yep, the forward voltage.
Forward voltage, that's it?
Yep.
The forward voltage is that up there?
Yep.
Sure, it's 3 volts forward.
Yes.
Okay.
Yep. Blue LEDs require a lot of voltage.
A little one, like a baby one.
Do you want to show them how to measure it with a multimeter as well? It's got a diode mode on it.
Oh, does it? Oh, okay, I didn't know that.
Everyone see what they see.
I actually haven't ever used that.
They've got.
It measures it's a good check because it'll measure the forward voltage. So you get, when they get back to their seat, they
Okay,
can check it.
yeah. I'll give it a shot.
Might prevent it.
I'll just try it before I do it.
So good because I think they
All right. Written down your numbers. Yes, yes, yes.
Do we do it at the highest point or the lowest point?
So components, unfortunately, in the real world, components are non-ideal, which means it's anywhere between those two voltages.
So I'm going to make it the highest point just to make sure.
Yes, that's what you should do. You should always work towards the worst case scenario.
So in this case, for the forward voltage drop, that would be the lowest voltage is the worst case scenario.
Yeah.
So everyone got their right voltages, so everyone's wired up correctly.
Yeah. All right, so everyone's got an LED, you've written down the number. What I want you to do is go to your multimeter and have a look on there. There's a button that looks like the symbol for the LED, just without the little arrows coming out of it. Everyone see that? And I want you to press it. Yep. You know, right, so if you want to grab the little legs of it and spread it apart a little bit, and then just hold the probes.
You can
when
actually,
yeah, you can touch it. Yeah.
so you can actually do that.
Yep. Yep. And then if you find it easier, the way I do it is there you go, look at that. So if you hold it on there, you just got to wait for it because it takes a little while for it to calculate. So there's a little thinking.
Is it meant to be an open or closed circuit?
It'll tell you a voltage on there when you hold it down. The LED will light up, it'll make a buzzing sound, and it will tell you the voltage of your LED.
Oh, wait, something just happened.
If you're finding it difficult to probe the legs of the LED, what I want you to do is plug it into the breadboard. I'll show you where it goes in. So, if you're finding it difficult to measure the legs of the LED, what I want you to do is take the LED itself and plug it into the breadboard so it's vertical, just like that. And now you can more easily probe the legs. Oh, okay. So what I need you to do there first, if you have a look at the way, so when you're putting the LED into the board, have a look at the way it's positioned on the overhead and make sure it's positioned the same way. If you position it across the row, it's going to connect the legs together. Yeah. So you want to position it the other way around so it's not shorted. Yeah.
And just to sort of reinforce about not touching the probes together while you're probing anything, accidents will happen, we get that, but if everybody tries their microcontrollers, then we won't have any payload data for the rockets and we'll just be flying rockets. Because we don't have enough time or components to make new microcontrollers, and that will potentially destroy them. So please be very careful. So, and that means don't be afraid to ask questions either. If you're not sure before you do something, get one of us over, and we will help you. Because we want to make sure you guys get to fly your rockets with payloads.
Stop working.
Oh, there we go. Okay, I'll get Jacob.
Yep.
Sorry, I'm not.
Fried it.
So what are you trying to measure right now?
Breadboard or the LED?
It should still be. So what are you trying to measure?
Oh, no, you're not going to be able to do it on that one, unfortunately. That doesn't have diode mode. Oh, yes, yes it does, sorry. So we just got to flick that one up to the top there with the diode. Yeah, now try again. Try flipping the probes. Yep, so just switching around, because one will be positive, one will be negative. So the thing some of you might have noticed is that the LED only turns on when you measure it in one direction. And the reason why is because an LED is a polarized component, which means it only works in one way. That's what the line on the diode symbol means. It's this, that line indicates that current will not flow through that direction. Okay, so has everyone managed to get their LED to light up with the multimeter? What I want you to have to do is have a look at your LED, like physically up close, have a look at it. One side of the LED is going to have a little flat part. Can everyone see the flat part in the LED? Yep. One side will be flatter than the other. They'll also have different length legs.
You test with this one,
Can I have a look?
give you a measurement on the screen of the multimeter.
Shorter leg, so it's on this side here.
Okay.
Yeah. Not only will it have a flat side, there'll be one leg shorter than the other.
Is the longer leg negative?
The long leg is positive.
Oh.
Does it need to be on the same as the power?
So once everyone's got their LED plugged into their breadboard, what we're going to do is we're going to calculate the resistor that you need to power your LED correctly. So we're going to work off of 10 milliamps. I think that's fine. And we've got the same equation there as before. So if you've got, what do we do? We had our LED voltages. We wrote them down. We also determined them through the multimeter. Now everyone that's got an LED voltage written down, that is the V in your I equals V over R. And you want to calculate the R. So we're going to rearrange I equals V over R so that we have...
You need to do 3.3 minus the voltage.
Yes. Yeah, but I'm going to get there. Yeah. So we've got... we just mentally go through that. So I equals V over R, we want to calculate what the resistor is that we need to supply 10 milliamps to this LED. So the way we're going to calculate that is first by rearranging I equals V over R to solve for R, and we'll start with that. So has anyone got their pieces of paper? If you want to do it old school. A little bit of algebra. It's not quite as fun as plugging things in, but unfortunately a big part of electronics.